Today's topic is instrumentation of UV visible spectroscopy. So here we have three types of instruments: photometers, spectrophotometers, colorimeters. So by using these instruments, we are going to determine the percentage purity, like qualitative and quantitative analysis of the known and unknown samples. The following components are present in the UV visible spectrophotometers: source of radiant energy, collimating system, monochromatic system, sample holders, detectors and readout devices. So we will see one by one in detailed discussion. So this is the schematic diagram of spectrophotometer. So as we discussed in the previous slide, here we have the parts of spectrophotometers. One is light source, then collimatic system, then dispersing element is there, then we have sample containers, then detectors, finally readout devices. So this is the arrangement of all components of spectrophotometers in a similar manner. So first one, we have source of radiant energy. So requirements of an ideal source: so it should be stable and should not allow fluctuations, should emit light of continuous spectrum of high and uniform intensity over the entire wavelength region in which it is used. It should provide incident light of sufficient intensity for the transmitted energy to be detected at the end of the optic path. It should not show fatigue on continued use. The first source, so here we have in UV visible spectroscopy we have two different sources. One is radiation source for visible radiation, then source for UV radiation. So first we have to discuss the source for radiation, visible radiation. Here tungsten halogen lamp is used as a basic source for the visible radiation. Its construction is similar to household lamp. The bulb contains a filament of tungsten fixed in evacuated conditions and then filled with inert gas. The filament can be heated up to 3000 Kelvin. Beyond this, tungsten starts sublimating. It is used when polychromatic light is required. To prevent this, along with inert gas, some amount of halogen is introduced, usually hydrogen, so iodine we can use. So that's why the name itself gives tungsten halogen lamp. So if absence of halogen, so we require more heat to get the radiation. So for UV radiation, so we have hydrogen discharge lamp. So we can see the picture, so how the hydrogen discharge lamp works. In a hydrogen discharge lamp, a pair of electrodes is enclosed in a glass tube filled with hydrogen gas. Generally, the glass tube provided with a silica or quartz window for UV radiation to pass through. When current is passed through these electrodes, maintained at high voltage, discharge of electrons occurs which excites hydrogen molecules, which in turn cause emission of UV radiation in near UV region only. They are stable and robust. The second one, xenon discharge lamp. It possesses two tungsten electrodes separated by some distance. So we can observe in the picture, so how these two electrodes are separated. These are enclosed in a glass tube which quartz or fused silica and xenon gas is filled under pressure. An intense arc is formed between electrodes by applying high voltage. This is a good source of continuous plus additional intense radiation. Its intensity is higher than the hydrogen discharge lamp. The third one is mercury arc lamp. In mercury arc lamp, mercury vapor is sorted under high pressure and excitation of mercury atom is done by electric discharge. So just go through the figure. So how this discharge lamp are arranged. So then note, so the mercury arc lamp is not suitable for continuous spectral studies because it doesn't give continuous radiation. So if the radiation source having continuous radiation, then only that should be used for the spectral analysis. Then second one of component, collimating system. The radiation emitted by the source is collimated, so made parallel by lenses, mirrors and slits. So in that first we go through lenses. So materials used for the lenses must be transparent to the radiation being used. Ordinary silicate glass transmits between 350 to 3000 nanometer and is suitable for visible and near IR region. Quartz or fused silica is used as a material for lenses to work below 300 nanometers. The shape of lenses are given in the picture. And second one of collimating system is mirrors. So these are used to reflect, focus or collimate light beams in spectrophotometers. To minimize the light loss, mirrors are aluminized on their front surfaces. The third one, slit. Slit is an important device in resolving polychromatic radiation into monochromatic radiation. To achieve this, entrance slit and exit slit are used. The width of slit plays an important role in resolution of polychromatic radiation. So generally 1 nanometer width of slits are used frequently to get proper monochromatic radiation. Then fourth one of collimating system is monochromators. So it is a device used to isolate the radiation of the desired wavelength from the wavelength of the continuous spectrum. The following types of monochromatic devices are used are filters, prisms, gratings. The first one, filters. Selection of filters is usually done on a compromise between peak transmittance and band pass width. The former should be as high as possible and latter as narrow as possible. So here we have two types of filters are there. The first one is absorption filters. It works by selective absorption of unwanted radiation and transmits the radiation which is required. For example, glass and gelatin filters. So the given figure shows arrangement of absorption filters. So here we have different colors. So based upon the solution color, so we use different colors of filters. So here if you use green filters, that means the solution should contains its complementary color of red. So based upon the complementary color, so we are going to change the filters. Then second one is interference filters. It works on the interference phenomena. It causes rejection of unwanted wavelength by selective deflections. Just go through the picture. So here the light passes through filters, so it reflects the unwanted filters and absorbs the unwanted filter. It is constructed by using two parallel glass plates which are silvered internally and separated by thin film of a dielectric material of different refractive index. For example, here calcium fluoride, silicon oxide, magnesium fluorides are the materials used as a dielectric material. These filters have a band pass of 10 to 15 nanometers with peak transmittance of 40 to 60 nanometers. Then second of monochromatic system is prism. So prism is made from glass, quartz or fused silica. Quartz are fused silica is the choice of materials of UV spectrum. When white light is passed through the glass prism, dispersion of polychromatic light in rainbow colors. Rainbow occurs. Now, by rotation of the prism, different wavelengths of the spectrum can be made to pass through in exit slit on this sample. So, in first figure of above, so how the dispersion of the light takes place on the prism. So, when you pass white light, it gives a visible region of light with some dispersion angle. So, here we have two types of filters are there. One is chronotype filters and then second one is lithotype filters. In chronotype filters, so here we get reflections, and lithotype we get refractive. Then second one of monochromators, gratings. So these are the most effective one in converting a polychromatic light to monochromatic light. So again, gratings are in two types. One is in that first one, diffraction gratings. So these consist of large number of parallel lines that we can call as grooves, about 15,000 to 30,000 inches, is ruled on highly polished surface of aluminum. Just go through the filters there. When you pass the light on this grooves, so it will be diffracted to give proper wavelength which we require. The second one is transmission gratings. So it is similar to diffraction grating, but refraction takes place instead of reflection. Refraction produces reinforcement. This occurs when radiation transmitted through grating reinforces with the partially refracted radiation. So these two are the transmission gratings, how the light passes through the radiation and how it converts to the monochromatic radiation. So this is the basic comparison between two collimating systems in that prism and gratings. So prism is made up of glass which is useful for visible. If it is made up of quartz fused silica, that it can be used in UV. Where alkali halides are used as a prism, that should be used for infrared radiation. So coming to gratings, these are made up of a groove on highly polished surface like alumina. Then working principle of prism is angle of incident, whereas grating is law of diffraction. So coming to merits and demerits of prism, prism gives non-linear dispersion, hence no overlap of spectral order. Grating gives linear dispersion, hence overlap of spectral order should be caused. So this ends for today's lecture. So in next lecture we'll cover the topic, so instrumentation of UV spectroscopy. In that, detectors and application we will discuss.